Hello and welcome to the Bearded Mathman's YouTube channel. Hey, in this episode, what we're going to be talking about is writing equations. It's an absolutely fundamental idea and skill in algebra. It's not usually taught on its own, so I thought I'd just put this together as a way to get us started. So, here's what we're going to be doing. We are going to be talking about being given some information or a diagram or something like that, and being able to write an equation that matches our thinking. It's a huge part of literacy, perhaps at least half of it, right? I mean, if you can't write, well then, how literate could you possibly be? And of course, literacy is important because without literacy, well, then you're just insufficient. You're just doing math by memorizing rules instead of being able to read and write. So let's get into it, shall we? Now, the rules of math are PEMDAS, the order of operations. And they're used all the time, just like you use grammar and punctuation all of the time. Now, we have all of these symbols. In English, for example, addition or sum is a plus sign. And an exponent is a little superscript like this right here. I think you guys know all of these. So combining the order of operations and an English statement, a statement in words, combined with these symbols, well, that's really all we need to be able to do to be able to write equations in math. Now, sometimes formulas help. We'll get into some of those examples. So let's do a few examples just to get us started. And as we move through more and more advanced math, we'll be revisiting this idea quite frequently. But for now, just with basic algebra, let's get into it. So our very first example is going to be to write a number n. Seems silly, right? There you go, just the number n. However, that's often the trickiest part. It's like, well, how do you write a number n? That's it right there. So now, what if you were asked to write a number n that would be divisible by 5? Think about it for a second. If n's our number, and we want to write a number n so that's divisible by 5, well, it's got to have a factor of 5 then, right? There you go. 5n is a number in terms of n that is divisible by 5. So there you go, 5n. That's kind of that might be a novel idea for you, but that's how it works. So let's take it to the next step, right? What we're going to do now is we're going to write a number in terms of n that when we divide by 5, it has a remainder of 3. Well, we know we're going to use n, and we know we're going to use 5n because we want to be divisible by 5, right? But the remainder of 3. So maybe you could think of some examples. 18 would work, right? If you divided 18 by 5, it has a remainder of 3. 28 would work, right? So each of those examples just is 3 more. And that's exactly how it works. And that's all you got to do. And that works for any positive integer that we'd want to use for n. So any number you want to plug in works. It's a tricky thing, though, to go from this statement, these instructions, to being able to write the expression. It's a tricky thing. It takes some practice. A lot of the time, you're not really sure if you got it or if you're doing it right until after you evaluate what it is you wrote. For example, in this case. So if we picked, say, 100, if we put 100 in here, we would have 503. Well, 503 divided by 5, yep, it has a remainder of 3, which is exactly what we want. So let's move on to the next example, shall we? We're going to write an equation that matches the following. 4 more than the product of 5 and a number is the same as 14. Well, there's a couple things we got to be careful of right here. We need to make sure that we're articulating and translating all of the words we might see here in our statement to their correct math symbols. And there's a couple that I see that jump out at me. So 4 more is plus, product is multiply, and is means equals. Now, sometimes and means add, but in this case it doesn't because the and is describing the product of 5 and the number. So we could use x, we could use n for the number, doesn't really matter, but we have 5 times a number plus 4 is the same as 14. So 4 more than the product of 5x is equal to 14. You could write 4 plus 5x equals 14 as well. Either way, not too bad. You've probably had some experience with that when you were first learning about algebra and inverse operations in reading, but just wanted to throw that out there. So let's see another example. This one involves a circle, right? So suppose we have a circle And we're told that that circle has an area that's 49 pi, I don't know what unit it is, centimeters squared, something like that, right? Now, we're being told that we have to show that the circumference of this circle is 14 pi. I don't know what the units are, centimeters, whatever. So this is the first time where we actually have some formulas that are going to come into play, and we have to use them. You have to write out your formula first. I mean, you might be able to get it right some of the time, but if you want to be consistently right, you start off with the formula first, always. So the formula for the area of a circle is area is equal to pi r squared. Now this formula for the circumference is 2 pi r. Now, you could also write pi times d, but since we're dealing with radius, I think this would be a more logical formula to start with. All right, so now we know that the area is 49 pi. So we're going to go ahead and plug in 49 pi there, and we're going to solve for r. The reason we're going to solve for r is the only way I can figure out what the circumference is if I find the value of the radius. And I can use the area to do that. Now, in some ways, this is kind of confusing because they actually give us the answer for the circumference. What they're having us do is show that that's true. So let's go ahead and solve for r now. We're going to divide both sides by pi. We're going to take the square root. We get 7. Hopefully you're good at using inverse operations already. If not, well, it might be a good idea to go back and review some of that. Now, since we know that the radius is 7, all we got to do is plug that in right here. Plug in 7 for the radius. 7 times 2 is 14 times pi, 14 pi. There we go. We're done. So we started off with our formula, then we plugged everything in, and now we got it, right? So another big takeaway, a big idea is that you have to really make sure you read the information provided, that you understand if there's a diagram, that you understand all of the components, and that you use all of the information. If you do all of that, you're probably going to be okay. But you got to take your time. You've got to understand clearly what it is you're going to be doing. You have to understand clearly what's expected of you. Then you can dive in. Let's see another example. Example number 4. We have a triangle right here, and we're told that the perimeter of the triangle is 25 centimeters. We're given a dimension for each of the sides, 10x, 2x, and x minus 1, all in centimeters. And we're being asked to show that 13x minus 26 is 0. Wow, that's it. That's a really kind of a confusing thing if you've never done a problem like this. Well, once again, we have to use all of the information provided. It tells us right here that the perimeter is 25 centimeters. And I know how to calculate perimeter. Perimeter, you just add up all the sides. So you add 10x, and you add 2x, and you add x minus 1, and it equals 25. So we're using this as a clue. Now, a lot of the time, you're not sure if that's really the way you're going to do this or not, but at least you started, right? And if it doesn't work, if this isn't what you were supposed to do, well, then you can go back to the drawing board and build on whatever it is you figured out wasn't right about that. So what we're going to try to do is we're going to try to change this by combining like terms and maybe using a little bit of algebra to see if we can manipulate this to see if it's really equal to 13x minus 26 equals 0. So if we combine like terms, 10 and 2 and 1 makes 13, right? If you were to subtract 25 from both sides, well, this would be 0, and this would be 26. So there you go. So the way we got that is we started off by making sure we used all of the information provided, and this was a clue right here, that the perimeter is 25. So we started off by writing an equation for the perimeter. We manipulated it, and we got what we needed. All right, last example, example number 5. Now, this involves percentages, and maybe that's something you're a little rusty on. And if that's the case, then, well, sometimes you learn a topic that was difficult when you apply new things to it, or you apply new skills, or you apply it in a new way. So maybe this will make it make sense for you all of a sudden if you never understood percentages before. And if not, then it might be a good idea to go back and do a little review. I'll put a link in the description that will provide you with some help on percentages. So let's take a look at this. There's a watch, it's on sale. It's marked down by some percentage. I don't know what that is. And it has a new price. I don't know what that is either, but it's K percentage discounted, and the new price is N dollars. We're going to have to write an equation in terms of M, and M is going to be the original price of the watch. once we get that, we have to solve for m and show that this is what we end up with. Boy, that seems daunting. That seems overwhelming. Well, here's what we're going to start with. Let me explain why. If you have trouble with this, I don't think you could just jump to this right here, but I think maybe if I reverse engineer where this comes from, that maybe you would understand. So let's start off with something that's really easy. Let's start putting some numbers in for m and k and n in a different situation and see if we can create an equation that we can then modify to fit our situation, right? So we got a watch, it's $100, and let's say it's 35% off. Well, 35% off of $100 means that it's going to be $65. So the way that we would calculate that new price is you got the new price is equal to a percentage of the original. Now the way we get that percentage is we have to take 35% off of the original. So we're going to be subtracting. So 65% is what we're going to be paying. So we're going to be multiplying 65% times 100, and that's how we get our $65. Because 100 is the whole original price minus the discounted price, and that's how we're going to get our price of $65. So let's see if we can go ahead and put this all together here, shall we? Now, what this is right here is this 100. What this 100 is doing, it's taking this change of the percentage. It's taking these percentages and turning them into decimals. That's what dividing by 100 is. See, if you have 65% and you want to turn that into a number, well, that's 65 over 100. Same with 100%. If you had 100% divided by 100, then that changes that 100% into a decimal. And so what we have right here is we have 100% minus, because it's a discount, the percentage that we're discounted. Just like we did here, 100 minus 35. That's what this is. This is 100% minus our discount of k. Now that might be kind of confusing. You might need to give yourself a chance to think about that. And so if you need to pause the video, play around with it a little bit, rewind it, watch it, go ahead and do that. Give yourself time. Be patient. Okay, so now what we got to do is we have to solve for m. When it says show that the subject of the equation is m, well, that when the subject of the equation is m, that this is what we get, that just means solve for m. So we have to take this and solve for m. Now, just to make sure we're 100% solid, m's the original price. We have to multiply that original price by the discounted percentage. We do that by taking 100 minus the discount, and we turn it into a decimal by dividing that percentage by 100. So we have to solve this for m, and it's actually not so difficult because all we're going to have to do is multiply both sides by the reciprocal, right? These are going to reduce, and we're going to be left with, boom, there you go. So let's take a look at our ideas. We got to make sense of the information. You have to use formulas, and then you have to manipulate those formulas with algebra, and boom, you're done. Hey, if you would like to see more homework like this and some notes that you can review, I'll put a link in the description for my website, thebeardedmathman.com, where you can go find some of this. But anyway, here's some practice problems for you to start with right now. I hope the video's been helpful. If it has, give it a thumbs up, subscribe for notifications of future videos, and thank you for watching.